What is real? How do you define real? If you're talking about what you can feel, what you can smell, what you can taste and see, then real is simply electrical signals interpreted by your brain.
What if everything you see, hear, touch and feel isn't real? Imagine your life as a video game. Your choices pre-programmed, your world artificially created. A fabricated reality so convincing that even your deepest doubts feel like part of the design. Reality, as we know it, is under scrutiny. This statement has challenged everything we've ever believed about existence. Could our world, with all its complexity, beauty and chaos, be nothing more than a highly sophisticated simulation? From ancient philosophy to modern computational theory, the idea isn't just science fiction, it's a plausible scientific and philosophical model. In this documentary, we'll delve into the roots of this provocative hypothesis, explore the technological possibilities of creating simulations, and examine the clues hidden in the fabric of our universe. We'll dive into the unsettling question: what if everything you know about existence is a carefully programmed illusion? For centuries, philosophers have debated the nature of reality. Plato's allegory of the cave suggested that what we perceive might only be shadows of a truer reality. René Descartes proposed the idea of an evil demon deceiving us, planting false perceptions. Today, these thought experiments resurface with a modern twist. Backed by advancements in computing, quantum mechanics and digital physics, with technologies like virtual reality and artificial intelligence evolving rapidly, the line between reality and illusion is blurring. We'll also discuss why some of the brightest minds in science, philosophy and technology believe our reality might be simulated. Could it be that we're living in a sophisticated program, created by an advanced civilization, to study, entertain or experiment? But before we answer these profound questions, we must ask ourselves, where did this idea begin? How did humanity first question the authenticity of reality? For as long as humanity has been capable of introspection, we have questioned the nature of reality. What if the world we perceive is not as it seems? This is not a modern concern. It is an ancient inquiry that has threaded through the fabric of philosophy for millennia. In his seminal work, The Republic, Plato paints a haunting image of prisoners chained in a cave, their heads fixed so they can only see shadows projected onto a wall. These shadows, cast by objects they cannot see, form their entire reality. To them, the shadows are the only truth, even though they are merely reflections of something far greater. Plato's allegory challenges us to consider whether we too might be perceiving only a fraction of a greater reality, a reality obscured by our limited senses. Are we, like the prisoners, unaware of a truer world beyond our perception? Fast forward to the 17th century, where René Descartes introduced another profound scenario. Descartes suggested the possibility of an evil demon manipulating our perceptions, deceiving us into believing in a fabricated reality. This idea laid the groundwork for skepticism in philosophy, where one questions whether the external world exists independently of the mind. If such a deception were possible, could we ever trust what we perceive? Centuries later, these philosophical musings found their way into the digital age. With advancements in technology, the question of reality moved from abstract speculation to tangible possibility. Nick Bostrom, a philosopher at the University of Oxford, who in 2003 proposed the simulation hypothesis in his groundbreaking paper, Are You Living in a Computer Simulation? Bostrom's argument is built on a fascinating premise. If advanced civilizations possess immense computational power, they could create simulations of entire realities, populated by conscious beings like us. His hypothesis is grounded in a trilemma. First, civilizations typically go extinct before they reach a level capable of creating simulations. Second, advanced civilizations choose not to simulate past realities. And finally, third, if neither of the above is true, it is almost certain that we are living in a simulation. If even one civilization in the vast universe achieves this capability, the number of simulated realities could far exceed base realities, making it statistically likely that we exist in one of these simulations. Bostrom's work draws parallels to Plato's shadows and Descartes' demon, but places them in the realm of computational possibility. Instead of shadows or demons, we face questions about artificial intelligence, digital physics, and the power of advanced computing to craft realities indistinguishable from our own. But if simulations are so plausible, why would an advanced civilization bother creating one? What purpose could such a monumental effort serve? And is there a way to detect if we're inside one? To imagine the possibility of living in a simulation, we must first consider whether it's technologically feasible to construct such a reality. Over the past century, the exponential growth in computational power has transformed human capabilities, taking us from simple arithmetic machines to systems capable of modeling entire universes. This journey toward technological mastery lays the foundation for the plausibility of building simulations so advanced that they are indistinguishable from reality. In 1945, the world saw the birth of ENIAC, Electronic Numerical Integrator and Computer, the first programmable electronic computer. While ENIAC was revolutionary for its time, its computational power was laughably minuscule compared to modern devices. It could perform 5,000 additions per second, a feat dwarfed by today's smartphones, which perform billions of calculations per second in the palm of your hand. As decades passed, Moore's law, the observation that the number of transistors on a microchip doubles approximately every 2 years, became a guiding principle for technological progress. This consistent exponential growth in processing power has allowed us to simulate increasingly complex systems, from weather models to molecular interactions. The advent of artificial intelligence, AI, marked another leap forward. Machines capable of learning, adapting and mimicking human intelligence opened the door to creating lifelike simulations. Simultaneously, breakthroughs in quantum computing promise to shatter previous limitations. Unlike traditional computers, which use binary states, 0 and 1, quantum computers utilize qubits that can exist in multiple states simultaneously. This allows them to perform calculations millions of times faster than classical computers. Imagine a computer capable of simulating every atom in a human body, or replicating the interactions of an entire galaxy in real time. With quantum computing, such feats may no longer be science fiction. Today's video games are a microcosm of how far simulation technology has come. Games like The Sims, Minecraft, and Grand Theft Auto allow players to control virtual characters in lifelike environments. In just a few decades, we've gone from pixelated screens to hyper-realistic visuals powered by advanced graphics engines. Modern game worlds feature dynamic weather, complex ecosystems, and NPCs, non-playable characters, capable of learning and adapting to player behavior. For example, games like Red Dead Redemption 2 present such an immersive experience that players often describe the game world as alive. Every detail, from the movement of leaves in the wind to the behavior of wild animals, is meticulously simulated to mimic reality. With the advent of VR, the line between reality and simulation has blurred further. Devices like the Oculus Rift and HTC Vive allow users to step into entirely virtual worlds where they can interact with their surroundings in real time. Augmented reality, AR, meanwhile, layers digital information onto the physical world, merging the real and the virtual. These technologies are not just entertainment tools, they're also used in fields like medicine, architecture, and military training. Surgeons now practice complex procedures in VR, while architects design buildings in immersive 3D environments. These applications highlight the potential for simulations to recreate intricate, lifelike scenarios for practical purposes. As video games and VR advance, they showcase humanity's ability to replicate increasingly detailed aspects of reality. If we can simulate cities, weather systems, and complex ecosystems today, it's not far-fetched to imagine that future technologies could simulate entire universes complete with conscious beings. But even if the technology exists to create simulations, why would anyone go to such lengths to simulate an entire reality? What purpose could this serve, and what evidence might we find to confirm our suspicions? While advancements in computing and immersive technologies prove that constructing simulations is becoming increasingly feasible, the question remains, are we already living in one? Philosopher Nick Bostrom provided a compelling framework to explore this idea in his groundbreaking 2003 paper. His argument for simulism isn't based on wild speculation, but on a logical and statistical foundation that forces us to confront an unsettling conclusion. The likelihood that we exist in a simulated reality is extraordinarily high. Bostrom's argument revolves around three possibilities, collectively called the trilemma. At least one of these must be true, but which one? Let's examine each closely. Civilizations go extinct before creating simulations. The first possibility is a grim one. Civilizations capable of creating simulations never reach that stage because they go extinct. Humanity's future, much like any advanced civilizations, is fraught with existential risks. There are several significant threats to our survival. The destructive power of nuclear weapons continues to threaten global stability, posing a constant risk of nuclear annihilation. Additionally, runaway climate change could render Earth uninhabitable before we achieve the computational power needed for simulations, leading to a potential climate collapse. Global pandemics, whether natural or artificial, also pose a severe threat. Pandemics or engineered bioweapons could bring humanity to its knees. Furthermore, the very technology that could create simulations might also destroy us if artificial intelligence develops uncontrollable or malicious tendencies, leading to the risk of artificial intelligence going rogue. If all civilizations face these or similar risks, they may extinguish themselves before developing simulation technology. This would make the creation of simulated realities exceedingly rare or even impossible. Advanced civilizations choose not to simulate. The second possibility is less catastrophic but equally significant. Even if civilizations survive long enough to acquire the computational power to simulate entire realities, they may choose not to do so. Simulating sentient beings could raise profound ethical dilemmas. If simulated beings experience suffering or pain, it would raise questions about the moral acceptability of creating them for research or entertainment. Additionally, advanced civilizations might find simulations of past realities uninteresting, choosing instead to focus their resources on exploring their own universe or other endeavors. Even with advanced technology, running large-scale simulations might require vast energy resources that a civilization could prioritize elsewhere. If the vast majority of advanced civilizations abstain from simulating realities, the likelihood of our existence in one diminishes dramatically. We are almost certainly living in a simulation. The third possibility, and the one that Bostrom considers the most likely, is that we are already in a simulation. Here's why. Statistical likelihood suggests that if even one advanced civilization in the universe chooses to simulate realities, the number of simulations they could create would likely number in the billions or trillions. Compared to these vast numbers of simulations, the number of base realities, the original non-simulated universes, would be minuscule. If we assume that simulated beings would be indistinguishable from real ones, the probability of our existence in a base reality becomes infinitesimally small. Additionally, if simulations are possible, simulated beings might themselves create their own simulations, leading to layers upon layers of nested realities. In this infinite cascade of simulated worlds, the chance that our reality is the base version shrinks even further. This conclusion flips our understanding of reality on its head. If we accept the trilemma and reject the first two possibilities, it becomes overwhelmingly likely that our lives, memories, and universe are all part of a meticulously programmed simulation. Bostrom's argument is not just a philosophical curiosity. It forces us to rethink our place in the cosmos. Are we the product of an advanced civilization's curiosity, an ancestor simulation designed to study their past? Or are we part of a complex virtual world, created for entertainment, experimentation, or reasons beyond our comprehension? But if our reality is simulated, is there any way to detect the truth? Could there be evidence hidden in the fabric of our universe that proves or disproves the simulation hypothesis? If our reality is a simulation, it's reasonable to expect that it might leave behind subtle traces, anomalies or patterns in the fabric of existence that reveal its artificial origins. The universe is filled with mysteries, but none are as perplexing or as potentially revealing as the phenomena observed in quantum mechanics. These strange behaviors at the smallest scales of reality challenge our traditional understanding of the universe, offering tantalizing hints that reality might be programmed, much like a computer simulation. One of the most famous and enigmatic experiments in quantum mechanics is the double-slit experiment. Its results defy common sense and have profound implications for the nature of reality. Imagine a simple experiment. A beam of light is directed at a screen through two parallel slits. When unobserved, the light behaves like a wave, creating an interference pattern on the screen. However, when scientists place a detector to observe which slit the light passes through, the light suddenly behaves like particles, and the interference pattern disappears. This phenomenon suggests that the mere act of observation changes the behavior of light. In essence, reality seems to choose how to behave based on whether it's being observed. Such behavior aligns eerily with the concept of programmed reality, where a system only renders details when they are required for observation. akin to how video games render graphics only in the player's line of sight to conserve processing power. Now the question is this: the evidence of a simulation. While quantum mechanics doesn't explicitly prove simulation, the observer effect aligns intriguingly with the idea of a programmed universe. It raises the question, is the universe behaving this way because it is fundamentally computational, designed to optimize resources by rendering reality on demand? Another compelling line of evidence for simulated reality comes from the field of digital physics, which suggests that the universe operates on discrete, quantized units, similar to the pixels of a digital image or the bits in a computer. At the smallest scales, the fabric of the universe seems to break down into indivisible units, much like pixels on a screen. For example, space and time might not be continuous. They may exist as tiny finite chunks defined by the Planck length. Approximately 1.616 times 10 to the power of negative 35 meters is known as the Planck length. It is a unit of length in the realm of quantum mechanics and string theory. Planck time, derived from the Planck length, is the time it takes for light to travel one Planck length in a vacuum. Planck time is approximately 5.39 times 10 to the power of negative 44 seconds. Energy levels in atoms are quantized, existing only in discrete steps rather than a smooth spectrum. Physicist James Gates discovered that certain equations governing the behavior of fundamental particles contain elements resembling error-correcting codes. Codes that computer scientists use to detect and correct errors in digital systems. The presence of such codes in the laws of nature raises a startling possibility. Is the universe itself a vast computational system with built-in mechanisms to ensure stability and accuracy? If the universe behaves like a computer with discrete states and error correction, it suggests an underlying digital structure. This would be consistent with the simulation hypothesis, where reality is not continuous but instead runs on a programmed grid, like a hyper-advanced video game. Quantum entanglement further deepens the mystery. When two particles become entangled, their states remain connected, even when separated by vast distances. If one particle is measured, its partner's state instantly changes, as if they are communicating faster than the speed of light. This spooky action at a distance could be interpreted as a form of data synchronization in a simulated system, ensuring that entangled particles maintain coherence across the simulated universe. Quantum mechanics forces us to question whether reality operates like a conventional physical system or a computational one. The wave-particle duality, the observer effect, and the quantized nature of reality all point to an underlying system that behaves strikingly like a programmed environment. But if quantum mechanics hints at a simulated reality, what other evidence might be hidden in the cosmic code? Could mathematical and physical laws themselves reveal the fingerprints of the simulation? If our universe is a simulation, it stands to reason that its underlying structure might reveal traces of the programming that governs it. Mathematics, often referred to as the language of the universe, provides a framework for understanding the cosmos. But what if it's more than that? What if mathematics isn't just a tool for describing reality, but the very fabric of existence itself? In recent years, discoveries in theoretical physics and cosmology have unveiled peculiarities that suggest the universe may operate like a computational system. From error-correcting codes embedded in fundamental equations to the digital-like behavior of natural laws. Mathematics might hold the key to answering one of humanity's most profound questions. Are we living in a simulation? In the 2010 theoretical physicist James Gates made a startling discovery. While studying supersymmetry equations, mathematical frameworks that extend the standard model of particle physics, he found patterns resembling error-correcting codes. These codes, commonly used in computer science, are designed to detect and correct errors in digital systems, ensuring stability and accuracy. The presence of error-correcting codes in equations describing fundamental particles raises a provocative question. Are these codes inherent to the universe, or are they artifacts of a simulated reality? In a computational system, such codes would be essential for maintaining the coherence and stability of the simulation, much like how video games prevent glitches in rendered environments. The discovery hints that the universe might be governed by a form of digital architecture. If these codes were intentionally embedded, it suggests that the cosmos is not a random occurrence, but a meticulously constructed program. Another striking feature of our universe is the uncanny resemblance of natural laws to computer code. From Einstein's equations of general relativity to the principles of quantum mechanics, the mathematical elegance of these laws often feels designed. Many physical laws can be expressed as concise mathematical formulas, such as E equals mc squared or F equals ma. This simplicity is reminiscent of how programmers strive to write efficient, elegant code for complex systems. At the quantum level, particles behave in discrete steps, much like binary code in a computer. For example, electrons exist in quantized energy states rather than a continuous spectrum. The universe itself appears to have a finite resolution, with the Planck scale serving as its smallest pixel, the universality of mathematics. Its ability to describe phenomena as diverse as planetary motion, electromagnetic waves, and subatomic interactions suggests an underlying blueprint akin to an operating system running on a cosmic computer. In video games, the laws of physics are encoded into the system to ensure consistent and believable gameplay. Similarly, the natural laws of our universe might be the rules programmed into the simulation to maintain order and structure. In 2012, physicist Silas Bean proposed a fascinating hypothesis. If the universe is a simulation, it might exhibit computational limitations. Bean suggested that the observable universe could behave like a lattice or grid, much like the structure of a digital simulation. Bean's research highlights key points regarding cosmic lattice evidence and testing the hypothesis of a simulated universe. Bean argued that the distribution of high-energy cosmic rays might reveal signs of a simulated lattice. In a base reality, cosmic rays would be distributed uniformly. However, in a simulated universe with a computational grid, their paths might show evidence of constraints or boundaries. Bean's proposal opens the door for empirical tests. If patterns consistent with a lattice structure are found in cosmic ray data, it could provide direct evidence for a simulated universe. Error-correcting codes, quantized behavior, and mathematical precision all point to a question. Why is the universe so perfectly ordered? Random chaos would not produce the level of predictability and coherence we observe. Could this perfection be a result of programming, designed to keep the simulation stable and believable? But if our universe operates like a program, who or what is behind the code? Could it be an advanced civilization, an alien intelligence, or something beyond human comprehension? If our universe is indeed a simulation, one of the most tantalizing questions becomes who or what is responsible for its creation? Are we the product of an advanced civilization's curiosity, an experiment in artificial intelligence, or the work of entities far beyond our comprehension? Exploring potential creators takes us into the realms of philosophy, ethics, and speculative science. It challenges us to consider the motivations and capabilities of beings who might wield the power to simulate entire realities. The most widely discussed hypothesis is that a post-human civilization, descendants of humanity who have achieved unimaginable technological advancement, might be responsible for creating our simulated universe. The path to post-humanity involves two key concepts: technological singularity and mastery over reality. The technological singularity refers to a point where artificial intelligence surpasses human intelligence, enabling exponential advancements in science and technology. Mastery over reality suggests that post-human civilizations would likely have access to near-limitless computational power, allowing them to simulate not only planets or ecosystems, but entire universes, complete with self-aware beings. Motivations for creating such simulations could be curiosity and research, entertainment and experimentation, or ethical considerations. A post-human civilization might simulate past realities to study its own origins. Just as historians and archaeologists reconstruct the past using fossils and ruins, an advanced civilization might create detailed simulations of ancient societies to understand their evolution. Our thoughts, emotions, and cultures could be data points in a massive experiment aimed at unraveling the mysteries of their ancestors. The simulated universe could also be a form of entertainment, akin to a cosmic video game. In this scenario, the creators might observe or even participate in the simulation, interacting with us in ways that seem random or divine. Alternatively, the simulation could serve as a testing ground for hypothetical scenarios, allowing the creators to model complex systems or explore moral dilemmas. Ethical considerations arise if post-human creators simulate realities. Are they morally responsible for the beings they create? Do simulated beings deserve rights, or are we mere code without intrinsic value? Would they intervene in our world, or are they bound by an ethical prime directive to let the simulation run its course? Beyond post-humanity, there are other theories to consider, particularly involving alien civilizations. If humans can conceive of creating simulations, it is plausible that extraterrestrial civilization, potentially millions or billions of years ahead of us, could have achieved this capability. Aliens might simulate realities to explore hypothetical scenarios, observe the evolution of other intelligent species, or even communicate with beings like us through the framework of a simulated universe. If our creators are aliens, their motivations could be vastly different from our own, rooted in goals we cannot comprehend. Another possibility is that the creators of the simulation are not biological beings at all, but highly advanced artificial intelligences. The AI hypothesis suggests that if AI reaches superintelligence, it could decide to simulate universes as part of its programming or to satisfy its own curiosity. These simulations might serve as training grounds for the AI, enabling it to model complex problems or develop solutions for scenarios beyond its own reality. Spiritual or multiversal theories propose that the creators could be entities beyond our comprehension, akin to gods, whose motivations align with spiritual or metaphysical ideas. Alternatively, our universe might be one of countless nested simulations, each created by the inhabitants of another simulated reality. Signs of the creators in our reality might include Easter eggs and anomalies, much like developers of video games sometimes embed hidden messages or features. Our universe might contain clues pointing to its origin. Unexplained phenomena such as glitches in the Matrix, déjà vu, or Mandela effects could be evidence of creator intervention or system errors. If the creators exist, it raises profound questions about free will and autonomy. Are we merely puppets? Are actions predetermined by the simulation's programming? Or do we possess genuine agency within the rules of this artificial reality? The notion of creators also opens the door to unsettling possibilities. What happens when a simulation is no longer useful to its creators? Would they shut it down or let it persist indefinitely? But if there are creators, is it possible for us to escape their simulation or interact with them? Could we ever transcend the boundaries of our reality and discover what lies beyond the code? If our reality is indeed a simulation, it's natural to wonder whether the system is flawless or if there are cracks in the facade that we can exploit. Could there be signs within our world that hint at its artificial nature? From peculiar glitches to thought experiments designed to probe the boundaries of reality. The quest to hack the simulation is as intriguing as the possibility of the simulation itself. But hacking the code isn't just about exposing the truth, it's about understanding what lies beyond. If we can find the limits of this constructed universe, we may uncover its purpose, its creators, and even our role within it. Let's dive into the enigmatic clues and bold experiments that question the very structure of our existence. The idea of glitches in our reality gained cultural fame through science fiction, particularly The Matrix, but there are real-world phenomena that align eerily with the concept of programming errors. Déjà vu is the sensation that you've experienced a moment before, even though it's happening for the first time. The simulated hypothesis suggests that if reality is a simulation, déjà vu could be a programming hiccup, a moment when the system accidentally renders the same sequence of events twice. While neuroscience attributes déjà vu to memory errors, the phenomenon remains mysterious and tantalizing for those who believe in simulated realities. The Mandela effect describes collective false memories shared by groups of people. For instance, many recall Nelson Mandela dying in prison in the 1980s, even though he lived until 2013. These false memories might be evidence of alterations to the simulation's programming or glitches during an update. Perhaps we're living in a system that occasionally rewrites its own history, leaving behind residual traces of its original state. Such anomalies could indicate a dynamic, editable reality where even time itself is malleable. Instances of synchronicity, unaccountable coincidences, or even missing objects could be seen as signs of bugs or oversights in the simulation's coding. These subtle cracks, though often dismissed as imagination or coincidence, might be key indicators of a programmed reality. If glitches hint at a simulated world, scientists and thinkers have sought to test reality more directly. The goal? To identify flaws, inconsistencies, or boundaries that might expose the system's artificial nature. The search for cosmic evidence includes Silas Bean's cosmic lattice hypothesis, which proposes that high-energy cosmic rays might reveal signs of a computational grid underlying the universe. If such a lattice exists, it would indicate that our world operates on discrete, programmed units rather than continuous space-time. Quantum experiments, such as the double-slit experiment and quantum entanglement, remain active areas of exploration as they challenge the classical understanding of reality. These phenomena could be the product of a programmed universe attempting to conserve resources. Poking reality with thought experiments involves the simulation argument feedback loop, suggested by philosopher Nick Bostrom. He posits that our awareness of the simulation hypothesis could influence the simulation. If the creators are monitoring their system, the mass questioning of reality by simulated beings could trigger observable changes or reactions from the creators. Some theorists argue that meditative or altered states of consciousness might allow individuals to perceive the code behind reality, akin to a hacker accessing the back end of a system. In terms of computational challenges, creating AI within our world essentially simulates intelligence. Some researchers have proposed creating AI models that attempt to break the system by identifying patterns or inconsistencies in the universe. Scientists have also proposed simulated physics tests to determine whether physical constants, such as the speed of light, remain consistent at all scales. Any deviations could hint at boundaries or limitations in the simulation's framework. Philosophers and scientists alike have employed paradoxes to expose the potential cracks in our reality. These paradoxes, if unsolvable, might reveal the limits of our programmed universe. The Boltzmann brain. Paradox: if the universe is infinite, there's a higher probability that random fluctuations would create a single conscious brain than a fully formed universe. The fact that we exist in a seemingly coherent reality challenges this assumption, unless, of course, we're in a simulation designed to mimic order. The grandfather paradox. Time travel within the simulation could create logical inconsistencies, such as altering events that negate the existence of the time traveler. Would such paradoxes reveal limits to the simulation's programming? If reality is a simulation, there's a possibility that its creators are observing or even interacting with their creation. This raises profound questions. Observation tests. Do events in our world change when they are observed, as the double-slit experiment suggests? Could this indicate active monitoring by the creators? Intervention or independence? Are glitches and anomalies deliberate acts of interference, or are they unintended consequences of a vast and complex system? But if we truly are in a simulation, what does this mean for our existence? How should we live our lives knowing that our reality might be artificial? And how do we find meaning in a world that could be nothing more than code? If our universe is a simulation, what does that mean for our understanding of life, morality, and purpose? This realization could upend everything we know about existence, challenging our concepts of free will, ethics, and even the value we place on our experiences. Yet it also opens new pathways for reflection. Do we live our lives any differently knowing we might be simulated? Can we still find meaning and joy in a world that could be nothing more than code? Let us explore the profound philosophical questions that arise when we consider the possibility of living in a simulated world. One of the most unsettling implications of the simulation hypothesis is its challenge to free will. If we are part of a simulation, it raises the question, are our thoughts and actions genuinely our own? Or are they predetermined by the program running the simulation? In video games and simulations we create, non-playable characters, NPCs, follow scripts or algorithms. If our world is a simulation, could our choices be similarly constrained? While we feel free to make decisions, those decisions might be the product of predetermined programming, leaving us with the illusion of choice rather than true autonomy. Reconciling free will with simulation involves the argument that simulated beings can still have free will within the rules of the simulation. Just as a player in a video game can make choices within the game's boundaries, we may possess limited autonomy within the confines of our simulated universe. Advanced simulations might allow for emergent behaviors, meaning our thoughts and actions could arise independently of the original programming. This raises implications for responsibility. If our actions are programmed, are we truly responsible for them? Does morality still hold meaning in a deterministic system? The ethics of simulated beings raises profound questions. If we are simulated, should we care about pain, loss, and environmental destruction if they are all part of a program? From our perspective, simulated or not, suffering feels real. Physical pain, emotional distress, and environmental crises impact our lives deeply. If our experiences are indistinguishable from reality, does it matter if they arise from code? Additionally, if an advanced civilization created our simulation, are they morally obligated to ensure the well-being of the beings they simulate? Would simulated suffering serve a purpose, such as teaching lessons or testing scenarios? If the universe is simulated, is it still worth preserving nature, ecosystems, and the environment? Some argue that the inherent beauty and complexity of our world deserve protection, regardless of its origins. The intricate interdependence of ecosystems and the aesthetic and emotional value they bring to our lives are compelling reasons to care for the environment. Alternatively, others suggest that if everything is code, environmental preservation might only matter insofar as it affects our subjective experiences. From this perspective, the well-being and happiness of simulated beings take precedence, and preserving the environment becomes important only as it impacts our quality of life and mental well-being. If the universe is simulated, is it still worth preserving nature, ecosystems, and the environment? Some argue that the inherent beauty and complexity of our world deserve protection, regardless of its origins. The intricate interdependence of ecosystems and the aesthetic and emotional value they bring to our lives are compelling reasons to care for the environment. Alternatively, others suggest that if everything is code, environmental preservation might only matter insofar as it affects our subjective experiences. From this perspective, the well-being and happiness of simulated beings take precedence, and preserving the environment becomes important only as it impacts our quality of life and mental well-being. Does knowledge of the simulation change anything? For some, the idea of living in a simulation is liberating, freeing them from existential dread by suggesting that life has a greater purpose, whether as entertainment, research, or a cosmic experiment. For others, it's deeply unsettling, making them question the value of their relationships, achievements, and aspirations. Even if life is simulated, our experiences, emotions, and relationships remain real to us. Meaning can still arise from the connections we make, the joys we experience, and the legacy we leave behind, regardless of the simulation's nature. Stoic philosophers argued that meaning comes from how we respond to our circumstances, not the nature of those circumstances. Similarly, our simulated status need not diminish the value of our lives. Existentialist thinkers, like Sartre, emphasized creating meaning in a meaningless world. Whether simulated or not, we are free to define our purpose, living authentically. Some might choose to live boldly, embracing the possibility that their actions could be observed by creators or have unforeseen ripple effects in the simulation. Prioritizing experience, knowing life might be simulated could encourage a greater focus on personal fulfillment, creativity, and exploration, as these experiences remain meaningful to us. Human significance in the simulation is a profound consideration. If we are simulated, does it diminish our importance? Not necessarily, but our existence may be integral to the Creator's purpose, whether we are part of a grand experiment, a historical reconstruction, or a form of entertainment. Philosophical reassurance lies in the fact that, simulated or not, our existence means we hold value, if only as a testament to the power of consciousness and complexity. Living in a simulated universe does not eliminate the wonder of existence. In fact, it adds another layer of mystery. Why were we created? What lies beyond the simulation? But even if we accept that we are simulated, how do we find meaning in our lives? Can we forge a sense of purpose that transcends the nature of our existence? If our reality is a simulation, the next inevitable question is what lies beyond it. The idea that our world is part of a grander construct ignites the imagination, leading to tantalizing theories about what exists outside the boundaries of our programmed universe. Are we part of a nested chain of simulations? Is there a base reality where the ultimate truth resides? And most intriguingly, is escape from this simulation even possible? Let's venture into speculative territory, exploring what might exist beyond the simulation and what such a discovery would mean for us. Could the answers redefine our understanding of existence, or will they reveal mysteries even more profound? The idea of a base reality posits that our universe is part of a hierarchy, with the simulation we inhabit being created by beings in a higher level reality. At the top of this chain is the base reality, the original physical world from which all simulations derive. If a base reality exists, it would serve as the ultimate foundation of existence. The rules and principles of this reality would likely differ from those in our simulated universe, potentially revealing truths about matter, energy, and consciousness that we cannot yet comprehend. For those seeking answers about purpose, morality, and existence, the base reality represents the ultimate source of knowledge. But some philosophers argue that the concept of a base reality might be illusory. If simulations are possible, they could be infinite, leading to the possibility of nested simulations, a theory that raises even more questions. If simulations can create other simulations, our universe might be just one link in a potentially infinite chain, making it nearly impossible to discern whether we are close to the base reality or trapped in a deeper layer. It's conceivable that simulated beings might develop the ability to create their own simulations, perpetuating the chain of nested simulations. Are the inhabitants of deeper simulations any less real than those of higher levels, if there is no practical way to reach the base reality? Should it matter whether we are in a simulation or a nested one? Is it possible to escape the simulation? To escape a simulation, we must first recognize its boundaries. But how can we detect the edges of a system designed to be indistinguishable from reality? Searching for digital artifacts such as inconsistencies, pixelation, or computational limits might offer clues. These could manifest as anomalies in physics, unexplainable phenomena, or glitches in the matrix. Some theorists suggest that consciousness might be the key. If our minds are connected to the simulation's code, altering our perception or state of awareness might allow us to transcend its boundaries. Efforts by scientists and philosophers include quantum experiments proposed by physicists like Silas Bean, who have suggested using cosmic rays to detect the lattice structure of the universe, potentially exposing its simulated nature. Advanced AI could be programmed to search for patterns or inconsistencies in the universe that point to its artificial origins. By analyzing the structure of physical laws, scientists might uncover evidence of constraints or artificial programming. The prospect of escaping a simulation raises a profound question. What would we find outside it, if our reality is nested? Breaking out might only lead to another simulated layer, perpetuating the cycle. Escaping could lead us to the original, foundational universe, the base reality. But this reality might be so different from our own that it defies understanding. It's also possible that outside the simulation there is nothing, no physical space, time, or existence as we understand it. The simulation might be the only reality there is. The prospect of escaping a simulation raises a profound question. What would we find outside it? If our reality is nested, breaking out might only lead to another simulated layer, perpetuating the cycle. Escaping could lead us to the original, foundational universe, the base reality. But this reality might be so different from our own that it defies understanding. It's also possible that outside the simulation there is nothing, no physical space, time, or existence as we understand it. The simulation might be the only reality there is. Scenario 1, the test simulation. One theory is that our universe is a test, a controlled environment designed to study the evolution of intelligence, morality, or societal structures. If this is true, escaping might mean proving to the creators that we've fulfilled their experiment's purpose. Scenario 2, the infinite sandbox. Alternatively, our universe could be a sandbox simulation, with no fixed objectives or goals. In this scenario, escaping might not be possible or even desirable, as the simulation itself might be designed for perpetual exploration. Scenario 3, the creator's challenge. Some speculate that the creators of the simulation might deliberately leave clues or challenges for us to discover. Escaping the simulation might be akin to completing a cosmic puzzle, requiring ingenuity, collaboration, and perseverance. The possibility of nested simulations, a base reality, or escape fuels humanity's innate curiosity. The search for answers propels science, philosophy, and art, enriching our experience of the universe, simulated or not. But whether or not we ever find the truth, a deeper question remains: how do we live meaningful lives in the face of such uncertainty? Can we embrace our existence, simulated or not, and find purpose in the here and now? While the simulation hypothesis has gained traction in philosophy, science, and pop culture, It's far from universally accepted. Many scientists, philosophers, and skeptics argue that the hypothesis is either flawed, unfalsifiable, or unnecessary to explain the nature of reality. Let's discuss the key criticisms, explore alternative viewpoints, and examine whether the idea of simulated reality holds up under scrutiny. Criticism 1. The problem of unfalsifiability. One of the most significant criticisms of the simulation hypothesis is that it cannot be proven or disproven. In scientific inquiry, a hypothesis must be testable and falsifiable to be considered scientifically valid. The unfalsifiable nature means that if we live in a simulation, any evidence we gather could itself be part of the simulation's programming. Even apparent proof might be an illusion crafted by the creators. Critics argue that the simulation hypothesis, while intriguing, falls outside the realm of science and belongs more to philosophy or speculative thought. Supporters counter that just because something is difficult to test doesn't make it unworthy of exploration. Many scientific theories began as abstract ideas before technology advanced enough to test them. Criticism 2. The infinite regress problem. The hypothesis of nested simulations, where simulated beings create their own simulations, leads to a philosophical quandary. If simulations can endlessly create other simulations, where does it all begin? Critics question the assumption that a base reality exists at all. If there's no ultimate real world, the concept of a simulation loses its meaning. The notion of infinite regress makes it difficult to establish a coherent framework for the simulation hypothesis. Some theorists argue that infinite regress isn't necessarily problematic. Just as the multiverse theory posits an infinite number of universes, simulations could exist without a definitive origin. Criticism 3. The computational challenge. Skeptics question whether any civilization, no matter how advanced, could possess the computational power to simulate an entire universe with such precision. Simulating the interactions of billions of galaxies, each containing billions of stars and planets, would require an incomprehensible amount of energy and resources. While proponents suggest that simulations might render only what is observed, like in video games, skeptics argue that even this approach would demand extraordinary computational capabilities. Supporters suggest that future civilizations might discover entirely new forms of computation, such as harnessing quantum mechanics or black hole energy, rendering our current understanding of computational limits irrelevant. Criticism 4. Lack of direct evidence. Despite decades of speculation, no definitive evidence supports the simulation hypothesis. While phenomena like quantum mechanics and error-correcting codes are cited as potential clues, skeptics argue that these can be explained within the framework of traditional physics. The observer effect and entanglement, while strange, do not necessarily imply simulation. Critics argue that the universe's mathematical nature might reflect its fundamental structure rather than evidence of programming. Proponents argue that the lack of evidence doesn't disprove the hypothesis. They suggest that discovering the code of the universe may require entirely new methodologies or technologies. Criticism 5. Philosophical and ethical challenges. Some critics argue that the simulation hypothesis adds little value to our understanding of existence, whether we are simulated or not. Our experiences and emotions feel real to us. If the hypothesis leads to nihilism or apathy, For example, nothing matters because it's all a game. It could have harmful social implications. Proponents argue that the hypothesis encourages curiosity and exploration rather than apathy. It challenges humanity to think beyond traditional boundaries, inspiring philosophical and scientific growth. Criticism 6. Alternative theories. Critics propose that the universe's mysteries can be explained without resorting to simulation. Instead of simulations, some suggest that we live in one of many universes, each governed by its own set of physical laws. The universe's apparent design could arise from natural processes, with complexity emerging over billions of years rather than being programmed. The simulation hypothesis occupies a fascinating space between science, philosophy, and imagination. While it has captured the public's interest and inspired groundbreaking discussions, it also faces legitimate challenges. For skeptics, the hypothesis is an entertaining thought experiment rather than a serious explanation of reality. For proponents, it represents the next frontier of inquiry, forcing us to confront fundamental questions about existence, consciousness, and the nature of reality. But regardless of whether the simulation hypothesis is true or not, the deeper question remains: how do we navigate the mysteries of existence and make the most of the reality we experience, simulated or not? We began this exploration with a simple yet profound question. What if everything we know is an illusion? The simulation hypothesis, once the domain of science fiction, has grown into a serious philosophical and scientific inquiry, challenging the boundaries of human understanding. From philosophical roots, we traced the idea back to Plato's allegory of the cave and Descartes' evil demon, discovering that humanity has questioned the nature of reality for millennia. We explored the exponential growth of computational power, the rise of virtual realities, and the plausibility of creating simulations indistinguishable from reality. From quantum mechanics to error-correcting codes, we examined clues that suggest our universe might behave like a programmed system. We considered who or what might be behind the simulation: post-human civilizations, alien intelligence, or even advanced AI. We delved into the anomalies, thought experiments, and scientific efforts that aim to test the boundaries of our reality. Finally, we grappled with the moral, existential, and personal implications of living in a simulated world, questioning how this knowledge changes our understanding of free will, purpose, and morality. The journey through these chapters has been more than an intellectual exercise. It's been an invitation to challenge everything we thought we knew. The simulation hypothesis isn't just about science or philosophy. It's about confronting the deepest mysteries of existence and redefining our place within the cosmos. Whether we are in a simulation or not, the question of meaning remains. If the universe is a simulation, it doesn't diminish the reality of our experiences, emotions, and connections. After all, to us this world is real. The love we feel, the struggles we endure, the beauty we witness, these are the moments that define our humanity, regardless of their origins. If we are simulated beings, our creators may be observing how we live, how we treat one another, and how we respond to the challenges of our world. Perhaps the simulation is a test of our moral and ethical growth. If we exist in a base reality, our choices hold direct consequences for our world and future generations. In either case, our actions ripple outward, shaping the world we inhabit and the legacy we leave behind. The simulation hypothesis reminds us that life is, at its core, a mystery. But instead of being paralyzed by uncertainty, we can find empowerment in the unknown. Live with purpose, whether we are characters in a cosmic game or inhabitants of a base reality. We have the power to create meaning through our actions, relationships, and aspirations. Seek knowledge, continue questioning, exploring, and expanding the boundaries of human understanding. The pursuit of truth, whether about the universe or ourselves, is a journey worth taking. Cherish the present in a simulated or real world. The moments we share and the lives we touch are undeniably meaningful. Whether real or simulated, our choices matter. How will you live your life knowing it could all be a game? Will you strive to make a difference, uncover the truth, or simply savor the beauty of existence? The choice, simulated or not, is yours.